Welcome to the Building Ventilation Summit. Created and hosted by AMCA Australia, the summit is designed to ignite an important national conversation regarding building ventilation and its role in managing the spread of COVID-19. We would like to thank our event partners for supporting the Building Ventilation Summit.
Good morning and welcome to the second day of the Building Ventilation Summit, hosted by AMCA Australia. For those of you who weren't able to join us yesterday, my name is Ben Hawkins and I'm the Executive Manager of Policy and Communications at the AMCA. It's my great pleasure to be with you today as your host. Before we launch into today's program, I'd like to acknowledge the traditional owners of the land upon which we all join the summit today. We are broadcasting from Wurundjeri land in the eastern suburbs of Melbourne. So I pay my respects to elders past and present, and I extend that respect to the elders on whatever land you are watching the summit from today. I'd also like to take this opportunity to thank our event partners for their generous support of the summit. Victorian Government, Victaulic, Milwaukee, Reece, Windsor Insurance Brokers. As we all know, events like this simply don't happen without committed partners. So we're very grateful for all our partners for their generous support. Without further delay, let's get into session one. First up, we have Kate Cole from Cole Health. Recently awarded the Order of Australia for her reassuring voice throughout the pandemic, Kate is a multiple award-winning scientist and engineer who has helped improve the life of workers across some of Australia's most iconic projects. She's been named one of the top 100 women of influence by the Australian Financial Review and a superstar of STEM by Science and Technology Australia. Kate is the current president of the Australian Institute of Occupational Hygienists and sits on various committees and panels, enabling her to advocate for the health and wellbeing of workers across Australia. I'd like to hand over to Kate now to speak about how improved ventilation can help business leaders provide safer, healthier workplaces in the COVID era. Over to you, Kate.
Well, thank you very much. Thank you for the invitation to be here and to speak at such an important summit. I would first like to acknowledge the traditional owners of the land that we're meeting on today and to pay my respects to elders past, present and emerging. First, I want you to ask yourself a question. When you look at this picture, what do you see? Do you see the architecture? Do you see the ventilation? Do you see the layout of the desks? As an occupational hygienist, we instantly see the people. We see instantly how they work, what they're doing, the things going on around them, how they interact with the workplace. Our profession centres on keeping people safe, and so people are our focus. But this is not the perspective that all other professions see. From my experience on state and national task forces and panels during the pandemic, infection control in hospitals focus on the patient and how to keep patients safe, not always necessarily how to keep the workers safe. Ventilation or mechanical engineers may rightly focus on the ventilation system. Architects may rightly have a different area of focus. All of these are incredibly important. The end goal of all of our professions is the same, which is essentially to be safe and to be productive. We just all see this through different lenses. But a multidisciplinary approach to keeping people safe indoors will always have a better outcome than if we just look at the problem through one lens only. But today I'm going to take you through my lens as an occupational hygienist. So I should probably clarify what we're trying to keep people safe from. In today's climate, I obviously mean safe from transmission of COVID-19. And in this context, keeping people safe heavily relies on knowledge of how the virus is transmitted. So we know the virus is carried through fine respiratory droplets known as aerosols. We know that these aerosols range in size. Some are large, some fall to the ground quite quickly, but most are small, and most are capable of remaining in the air or being airborne, indeed for many hours. And understanding this is crucial because it informs everything from our assessment of risk through to the types of control measures or interventions that we need to mitigate that risk and how we might assess the effectiveness or how well all those control measures are doing. Conversely, a lack of understanding of how COVID is transmitted can lead to unsafe workplaces. And we've seen that, unfortunately, in healthcare and in hotel quarantine or aged care, for example, in previous waves of infection. If an employer only focuses on hand sanitizer and QR codes or posters, they're likely not appropriately keeping people safe. And I'm not going to repeat the fantastic work of distinguished Professor Lydia Morawska, or indeed the other amazing speakers that this summit heard from yesterday. Rather, I'm going to show you how we as hygienists use all this myriad of information that we have and how we put it into practice. But first, I'm going to start with the why. I mean, why do you need to keep people safe indoors? I realise I'm speaking to quite an educated audience on the topic, but it's important not to lose sight of the why, because I'm going to be honest and say, I don't think some people understand why they need to. So I might start with the basic reason of why you should want to, and that's workplace health and safety law. These are state-based laws that probably most of us know, and the majority of our states follow the harmonised Work Health and Safety Model legislation. And in the Model Work Health and Safety Act, it includes a primary duty of care. So, for example, employers have a duty of care to ensure a safe workplace so far as is reasonably practicable, and to ensure that other people aren't put at risk, like visitors to that workplace, for example. So this duty to ensure the health and safety of workers so far as is reasonably practicable takes into account a whole bunch of things. And those things include the likelihood of the hazard or the risk occurring. At this point, community transmission is pretty high, it's pretty likely. The degree of harm that might result from being exposed to that hazard and risk. Then what the person knows or what they ought to reasonably know about the hazard and risk, and how they might eliminate or minimise that risk. And that's commonly referred to as the state of knowledge. And the availability and suitability of ways to eliminate or minimise that risk. And then after all of that, after assessing the extent of the risk and how you might minimise or eliminate it, then it's the cost associated with the available ways of mitigating that risk and whether that cost is grossly disproportionate to the risk. So I mentioned the term state of knowledge, and that's the knowledge held by someone who is engaged in a relevant field of activity and not by reference to the actual knowledge of a specific person or someone's opinion in that particular position, for example. So you can't just put your head in the sand and say airborne transmission isn't a thing and I don't have to control ventilation, because let's be honest, you can Google this stuff now and it tells us that COVID is airborne and ventilation is important. The state of knowledge now is far more mature than it was at the beginning of 2020. So workplaces in many industries that we work across have the potential to be unsafe, that's granted. And while employers have to, they can control or in some way affect the conduct of people, of their own workers, they can't necessarily control everyone that comes into their workplace. But they can control and dictate the measures that people have to take whilst they're in their workplace and whilst workers are performing certain duties. I'll also add to the fact that employers that operate in really high-risk environments like healthcare doesn't in any way reduce the employer's obligations under the Act. To the contrary, it just poses a greater onus on employers to do more to ensure the health and safety of workers in that environment. So there's a greater level of care and vigilance expected to ensure that that obligation is met. So just very quickly, some basic examples of employers' duties include simple things like identifying hazards in the workplace and assessing the risks that those hazards create, and then eliminating and minimising them as much as possible. And I note there's a hierarchy of steps that have to be followed when managing hazards and risks in the workplace, and we refer to this as the hierarchy of control. Employers have to provide and maintain safe systems of work. So, for example, by providing sufficient and suitable staff or controlling entry into high-risk areas and providing appropriate safety equipment, for example. Keeping workplaces that they manage and control in a safe condition, free to risk of health, providing employees with the necessary information and instruction and training and supervision in appropriate languages to enable them to do their work in a way that's safe and without risk to health. So they have to tell them about COVID and the fact that it's airborne and what they're doing. And employing or engaging competent people, so people suitably qualified in work health and safety. And this is where occupational hygienists most commonly come into the picture to help advise them on employees' health and safety. And it's important to understand that ventilation specifically has been covered in our work health and safety framework for a long time. Work health and safety regulations provide a duty on employers to ensure that ventilation enables workers to carry out their work without risk to health and safety, so far as it's reasonably practicable. There's a requirement in the Act that employers ensure that the health of workers and the conditions at the workplace are monitored for the purpose of preventing injury or illness to workers. And this is backed up by codes of practices on managing workplace facilities. And there are specific clauses that deal with air quality, for example. But complying with the law should really be the basic reason why you want to keep people safe indoors. It is a sad day when employers need to be reminded of their legal obligations in order to act. The true reason why you should want to keep people safe indoors is that you realise that the biggest asset of your organisation is not the bricks and mortar. The biggest asset of your organisation is your people, and you should want to keep them. So, as I mentioned before, as an occupational hygienist, we work to prevent illness and disease in the workplace. Our focus is on the people who occupy the indoor spaces and how they use them, because that information is vital to create a multi-layered approach to keep them safe. And that perspective is important because we need to account for human behaviour and understand that every measure that's put in place to keep people safe may not be 100% effective. So we use this framework of the hierarchy of controls. It's a step-by-step approach to eliminate or reduce risks, and it ranks risk controls from the highest level of protection and reliability through to the lowest and the least reliable amount of protection. So applying the hierarchy works equally well whether we're protecting workers from asbestos, coal dust, radiation, heavy metals, or whatever workplace hazard we happen to be dealing with. The actual measures are different, but the framework is the same. So very quickly, eliminating the hazard is the highest level of control and the most effective. If you have no people indoors, then you have no risk, right? But it's not going to be reasonably practicable in the majority of cases. Then we get to substitution, which relates to substituting the use of a, high-risk product with a lower-risk product, or, for example, substituting a person for a machine that may do the same thing. Next, we get to engineering controls, which is where ventilation and safe indoor air really comes in. And then administrative controls or processes that we want people to follow, whether it's QR codes or testing, isolation, all falls into that category. Reducing the risk through the use of personal protective equipment is the lowest level of control on the hierarchy, not because it's not effective on its own. Masks are incredibly effective, but they are heavily reliant on human behaviour to be effective. Really simple example. This is what basic mask wearing is supposed to look like. But unfortunately, in our reality, this is what mask wearing sometimes looks like, or my personal favourite, this one. In contrast, once the ventilation system is set up well, it's harder to fiddle with it and stuff it up. And the mechanical engineers everywhere are sighing, going, it's really easy to stuff up my ventilation system. I know it is, but stuffing up mask wearing arguably is easier. Notwithstanding poor mask wearing, we know that public health orders are removing mask wearing requirements indoors, which some employers will unfortunately follow, which only increases our necessary focus higher up the control hierarchy to important items like ventilation. If you don't have people wearing masks indoors, your risk is going to be higher. Pandemic's not over. Virus is still in our community. So employers are going to need other measures to reduce that risk if they decide to get rid of mask wearing. So to figure out how to keep people safe indoors, you need to understand what makes a space safe or unsafe, right? Not exactly. Unlike what politicians or the media might suggest, there is no fine dividing line between what is safe and what is unsafe. There is no magic switch that I can turn on instantly that makes an unsafe space safe. It all relates to risk and the level of risk that is acceptable, and there is no zero risk scenario here. Workplace health and safety law requires that employers put more control measures in place when there's a higher risk and less for a lower risk situation, which makes sense, right? Because that's why you might see negative pressure rooms on a COVID ward, but perhaps not at your local shopping centre. Similarly, it's why you'll see us call for P2 or N95 respirators when community transmission goes up or it's really high. Importantly, the legislation is clear. It's not what businesses can afford, it's what is reasonably practicable. So let's just quickly review the types of risk factors that we consider for COVID-19 infection in indoor spaces, known as the infection risk parameters. Here's just some of them. Firstly, probably the biggest driver, the level of community transmission. So no transmission or low transmission equals low risk, right? Higher transmission, higher risk of infection. Well, generally so. Secondly, the more people you pack into a space, the higher the risk is going to be. More people, more aerosols, high risk. What people do in that space really matters. Are they sitting quietly, like they're in a library, or are they working out in a gym? If they're working out in a gym, they're generating a lot of aerosols, they're breathing more, the risk is going to be higher. How long people are indoors matters. The risk is going to be greater if someone's inside all day, and it's going to be lower if it's just for 5 or 10 minutes. We need to know what the ventilation is like. More fresh air, lower risk, less fresh air, higher risk. If the outdoor air ventilation is substandard, is there other supplementary systems that have been installed, like air cleaners, for example? We want to know how close people are to each other. Near field transmission within a few metres is just as important as far field transmission on the other side of a room. So we need to take that into account when we're looking at how to assess that risk. And then lastly, really simply, are people wearing masks? If they are, what's the type? Have they been trained? Are they worn correctly? At a high level, these are some of the parameters that we use to assess the risk of infection. Obviously, the higher the risk, the more controls we need. But the risk will likely not be the same throughout an entire building. It's important to look at every individual space that is occupied. So, for example, when reviewing a risk assessment for a school, I saw that some classrooms were higher risk and some were lower risk, even though they're the exact same size with the same amount of fresh air being delivered into those spaces. It was primarily because the activities being done inside those spaces and the amount of people that use those spaces were very different. Some teachers' break rooms were really high. Some of the area of the library is higher than others. The risk is not going to be the same everywhere. So applying blanket rules to every indoor space just doesn't work. But the understanding and the principles of applying them is important. So how do you reduce infection risk? Well, I guess to us, it's pretty basic, and to many of the people, educated people in this summit will also be pretty basic. But the important thing is to sort of put it into a system and make it really straightforward. Some of the most effective measures include reducing the number of people that you've got indoors. Can some do the activity outdoors? Can some work from home to reduce the occupation density, for example? Can they reduce vocalization? Do people need to shout or raise their voices, or can they use microphones to amplify their voices, less aerosols? Can you avoid or reduce intense physical activities indoors? Can that dance class that was previously done at a gym in the school now be done outside on the oval? It will reduce the risk to everyone in that space. Can you shorten the time people spend indoors, so shorten the duration of occupancy? Can you increase the amount of outdoor air being delivered into that space? I mean, I don't have to tell you how to do that. You might disable demand control systems. It might be maximising outdoor air intake, all of those things. How do you actually get more fresh air into that space to lower that risk? And then, can you improve ventilation effectiveness? Do you have to, or could you apply additional virus removal measures such as proven technology like HEPA? Much of this has been discussed at this summit. Can you space people out from each other to mitigate short-range transmission? But ventilation is all about far-field transmission, right? It's all about diluting or getting rid of aerosols in a space that we still have to account for people being close to each other. And can we use masks, or even better, can we use high-quality, well-fitting masks? In some cases, depending on the space, the answers will be yes to some of these, and they're going to be no to others. It's all about what that level of risk is that's acceptable and how practicable putting all these measures in place will be. Nonetheless, multiple layers are needed to keep people safe indoors. There is no one size fits all, and there's no silver bullet, unfortunately. And it's important to understand that these things are not set and forget. There is an obligation under work health and safety law, and I mean, it makes sense, to be honest, that there are routine checks in place to determine if the control measures or the things that you put in place are working effectively. And with regards to ventilation, there are lots of ways that this can be achieved. There is no right or wrong answer. Some things are relatively straightforward, carbon dioxide monitoring as a proxy for infection risk, with due regard to the limitations of that. Some require more specialised expertise. There may be tracer gases, SF6, other methods. Every method brings with it a pro and a con, and it's about what's suitable for the work environment and the space it's being used in. But my important takeaway is that a risk assessment is only words on a page and somewhat quite meaningless unless you put controls in place and then test how effective your control measures are. It's not a set and forget exercise. And if you're having outbreaks of COVID-19 in your workplace, there should be an investigation or a series of investigations to determine why and what from and what can be improved, and put those improvements in place to prevent them continuing to happen. If you're assuming that the level of infection risk is low, but you're not doing any on-site testing or monitoring, then really you're missing the point. So perhaps to some of you, this all sounds like complete common sense, and I haven't told you anything that you didn't already know. Well, I'd like to share some of my traps for young players, or errors that we've seen applied where there have been attempts to keep people safe indoors, because clearly this is not common knowledge for everyone. So my first example of poor practice is assuming that ventilation systems work optimally as per their original design. So an employer hires a section or a series of rooms in a building. They occupy that space. They may ask for ventilation information from the building owner. They get a series of schematics, and they assume that that ventilation system that was installed 10 or 20 years ago works optimally just as it did when it was first installed, and that zero modifications have ever been made. We all know that that's not necessarily true, and that there needs to be a few checks and balances done there. But unfortunately, this is quite common. The second example of poor practice, look, cleaning surfaces. Assuming that cleaning surfaces is the primary measure to reduce risk indoors. Newsflash, it is not. Assuming that split systems equate to fresh air provision. I mean, we all know what ventilation is, but we have to, I guess, communicate to a wider audience, including the general public, that split systems or things that recirculate the air aren't actually bringing in fresh air from the outside. Unfortunately, it's not necessarily common knowledge, and well-meaning employers will think that their split system is actually helping them reduce infection risk when likely it is not. Assuming that everyone wears masks perfectly all the time, and therefore a focus on ventilation is not needed. That is not true. And we've seen this where in some businesses, they will have workers that will be required to get into a vehicle and transport members of the community or other people, and they'll say, well, the best control measure for you to wear is a mask, and have no regard to the need to make sure that there's not air on recirculation in that vehicle, or windows don't have to be down, or just assuming that that mask is all that they need. That is a flawed assumption. Equally, thinking that all masks are equal and leaving high-risk workers in surgical or cloth masks. Look, a P2 N95 respiratory protection really is the minimum for an airborne virus, and if we do have workers that interface with members of the public who are at risk of having COVID-19, they need to be in respiratory protection. Assuming that the focus of the controls need to be where the majority of people are located. For example, there is so much focus on schools, and there absolutely needs to be. But a lot of that focus has been on classrooms, which is important. But what about where teachers go to eat? What about the toilets? What about the tea rooms? All of those areas are also equally important, yet the focus seems to be on the classrooms. Equally, in hospitals during the second wave, we saw a huge focus on negative pressure rooms. What about the waiting room? What about when nurses and healthcare workers have to go and eat? They're still indoor spaces, and they still need to be assessed, and arguably probably have different types of control measures to other areas of a building. Assuming that people don't travel. So there's always a lot of focus, hopefully, on the buildings themselves, but how do workers get from building A to building B? Do they take a long unventilated corridor to get there? Do they go in a vehicle? What are the controls in place to protect them during that transportation? Assuming that control measures are set and forget. So an employer's done a risk assessment, it's documented, it's been communicated, and they think that that's it. That is not it. You have to go and monitor how effective these are and make improvements where you can. And lastly, common theme, assuming that an infection risk is equal across every indoor space of a building, and therefore applying blanket measures equally is fraught with danger. So I want to sort of round up as what I see one of the key challenges that we have in truly addressing airborne transmission inside buildings. When a disease is spread by droplets, and the standard controls are hand hygiene and cough etiquette and cleaning, it's pretty straightforward, right? I mean, if we ever have a pandemic with a virus that's transmitted by droplets, like, we are golden. We know what to do. I don't know if that's ever likely to happen, but if it did, you know, we're golden. It's really simple. How hard is it to, you know, use some hand sanitizer and cough into your elbow? It's not rocket science. But when a disease is airborne and it needs ventilation as intervention, the main intervention, it gets really complex. The science behind it is complex. Not everyone can DIY their own HVAC system at home or at work. And this is how some people see it. We know this because we've seen ventilation really poorly done in hotel quarantine and aged care and other areas. So a key challenge that we have as a collective is to take all this complexity that we have with airborne transmission and ventilation and simplify it for businesses. And when we engage with employers collectively, regardless of our profession, it's important that we communicate the why, the how, and the what of safe indoor spaces relatively simply, because we need to demystify all of this complexity and provide really easy tools for people to know how to engage and know how to keep people safe indoors. Last year, I collaborated with a team of multidisciplinary experts at Aussage to do just that, and we created relatively simple, straightforward guidance that anyone can access and help create and enable safer workplaces during the pandemic. It's simple, it's straightforward, it's basically what we needed. It was never designed to account for every workplace situation, but hopefully it simplified the mystery of keeping people safe from airborne transmission. And I guess this is why when I speak on this topic that I use pictures and I use simple terms that non-experts can understand, because unfortunately we still have a long way to go to educate and support employers and our wider community on what we need to do. Our wider challenge is that we still have buildings in this country that haven't even had a ventilation assessment done. they're owned by employers that don't understand that airborne transmission is a risk, and that they are already obligated to do something about it. They may not have a ventilation system, and they simply think that opening a window is going to be okay, or worse, that providing hand sanitizer and a downloadable poster from the Department of Health somehow fulfills their health and safety duties. At this summit, we have heard some incredible technical detail. We've heard some limitations of some certain approaches, why some approaches are better than others, and these are all true, and it's so important for us to share that knowledge. But while it's important for us to openly discuss the technical details within our own expert community, equally, it's as important for us to work to simplify and demystify the important steps that employers can take to keep their people safe. And how we're going to get there is through continuing to work together collaboratively. I thank the AMCA for organising a summit like this, because individually, each one of our professions is absolutely incredible. But when we work together, that's when we start to see a true step change. So I'd like to thank you for your time this morning in listening to me, and hopefully I've helped explain the why, the what and the how of how we keep people safe indoors. So thank you very much for having me.
Thanks, Kate. Look, as you touched on, I'm glad you mentioned AusSage. Jeff Hanmer yesterday and Lydia Moraska are both involved in AusSage, and they do have some incredibly useful resources and information up on their website. So I encourage you to check it out. And as you also mentioned at the end there, Kate, we've heard a lot about technical challenges, policy, regulation, reform the last day and a bit. But it's important to bring it back to why this issue is so important, and that's about keeping people in our community safe, and you've definitely done that today. So I thank you for that. On a personal note, you promised a fabulous presentation when we caught up last week, and you certainly delivered, so thanks, Kate. Okay, so next I'd like to welcome Professor Rob Adams, Director of City Design and Projects at the City of Melbourne. Rob has over 46 years' experience as an architect and urban designer, including 35 with the City of Melbourne, where he's made a significant contribution to the rejuvenation of the city. During this time, he's guided countless major projects, including Council House 2 in Melbourne, the first commercial building in Australia to achieve a 6-star Green Star rating. Having received more than 150 state and national awards for design excellence throughout his career, Rob was made a member of the Order of Australia in 2007. So now I'd like to hand over to Rob, who will provide some lessons from the Council House 2 project and ponder what the future of an office building might look like. Over to you, Rob.
Thanks very much, and thank you for the opportunity of being with you this morning. I'd just like to start by acknowledging I'm speaking to you from the traditional lands of the Wurundjeri Woiwurrung people of the Eastern Kulin Nations, and I'd like to pay my respects to their elders past, present and emerging. If I could have the first slide, Dominic. CH2 was a project that was finished in 2006, and it was an experimental project, but it had two main objectives. The main objectives were to create a Green Star building that reduced energy consumption, because we saw this as one of the biggest impacts on greenhouse gases in our municipality. The second one was to provide the in-house healthy working environment. We experimented with many things in this building because it was a first, and we wanted to look at things that might work and things that couldn't work. But the main thing was, one of the major initiatives, as I say, was a night purge and good ventilation in this building. So if I could have the next slide. You can see on the right-hand side there many of the initiatives that were in this building. It had wind turbines, it had solar panels, it had planting on the facades of the building, it had wooden screens that sheltered the western facade. We took water out of the sewer and purified it. It was a building of 12,500 square meters, so a reasonable sized building with a lot of staff. But one of the important things in this was that it was built and designed, if you could go back one, Dominic, thanks. No, just onto the next one, please. It was built and designed to really work with this particular climate. And buildings that are specifically designed for climate can't be transferred to others. So this relied on an understanding of the temperatures and how those could be used, and the air quality and how that could be used. Next, Dominic. One of the principles, I brought a colleague of mine that I'd worked with in Zimbabwe out to work with our team, Mick Pearce. And Mick had been studying and built a building in Harare that used the principles of the anthill to ventilate his building in Harare, which was called Eastgate. And this looked at the climate and how it could use the climate to drag fresh air in and cool air in summer and ventilate the hot air out of the building. And this was a principle we applied to CH2. Next. One of the most important things in terms of cooling the building, but also in terms of purging this building, but each day before the occupants returned, was the night purge. The simple ability to open the windows at night, and when the temperatures on the inside of the building were greater than those on the outside in summer, the windows would open and air would flow through the building. And over these concrete ceilings that you can see in the right-hand slide, the thermal mass would be cooled like an ice block, and that could be then used to produce a good, clean air environment, but a cool environment in summer for the occupants. Next. Building was designed obviously for many modes. It had a summer mode, and in that summer mode, you can see on the right-hand side, timber shutters on the western facade to take the sun off that facade in the late afternoon. We had air that circulated through the floor and rose up to keep the occupants cool. We used things like phase change materials also to cool water. We had natural ventilation in the toilets by just allowing the air to flow past the toilets at the back of the building. We're drawing the air out. We had fresh air environments. Next, please. The winter mode was different. We had, for instance, plants on the northern facade of the building, and you can see those on the right-hand side. And they would lose their foliage over the winter, and you could get greater light penetration into the space to help warm up that space. And we obviously had to provide some heating, but heating in a building is not that important, and it was very small. The concentration was on cooling. Next one. The night mode, and here you can see the night purge being illustrated. So the air would flow through the building. The northern facade of the building was dark, and it had actually heated up during the day, and it would naturally pull the hot air out of the building. Next. And the final one was the day mode, where we were cooling the building through a number of mechanisms. We had chillers. We also had shower towers that cooled water. And we allowed this cool air to ventilate through and come out of the building. So that was much about how the building worked. Next. You can see here the two facades of the building were different in a couple of ways. The southern facade, which is on the left, light concrete because you were bringing cool air down in that. And the windows, because you were bringing air down from the roof, and it was 100% fresh air, you had larger ducts at the top, which are the panels you can see there, and therefore smaller windows. And therefore the light was regulated into the building. As you had more light further up the building, as you went down, you got greater size and window, and therefore more light. And the right-hand slide shows that the north face of the building was dark concrete, which helped ventilate the building. It naturally drew the air through. So although the air was pumped down from the roof, it was drawn out through natural ventilation on the northern facade. Next. I don't expect you to understand this slide, and I'll be honest, I don't particularly understand it myself, but the CSIRO told us that we were, if we were using air from the roof and we worried about the quality of that air, they measured it and they said, in fact, the quality was very high. And these were the figures that they gave us to prove that. And therefore, the air we were bringing into this building was of a very reasonable quality or high quality. Next. One of the secrets about CH2 was that we didn't try and condition the whole building. So those parts of the building that are shown in yellow here, the toilets, the back of house, the lifts, the foyers, the stairs, were all naturally ventilated. They were open to fresh air. And they weren't temperature controlled either. They really had the ambient temperature of that around them, although they were protected from the sun so they didn't become too hot in summer, and obviously with people using them, they were reasonably warm in winter. But we only conditioned that air that you can see in blue there. Next. But this is the secret to the ventilation system. What we had was a plenum underneath the floor. So the whole floor was a bit like a computer floor, raised 300 millimeters above the concrete slab. And the air that was brought down the side of the building and into it was introduced under the floor. It came in, we slightly tempered the air, we took moisture out of it, and I'll tell you why. And it came in at 20 degrees. Your body and your computer acted like a candle on this air. It drew the air past you, and it flowed past your body in a column of air up to the roof, where the slits in the roof drew that air out into the ducts that you can see there with the red circles. This meant two things. One, you're sitting in a reasonably confined fresh air environment, and if someone was close to you, the likelihood of you sharing their air was really reduced. And therefore, a high degree of separation just by the way the air was going through this building. The other thing is the temperatures in the building, because you didn't feel the hot air at the top of the room, you didn't have to, in fact, use a lot of energy to heat up air. Next slide, please. I show you this just because part of the construction to make this work, and this isn't possible, obviously, in existing buildings, and Dominic's going to tell you about how you can, in fact, work with existing buildings to produce the same outcomes that we've just seen in CH2. But when we constructed this, we wanted to use a lot of thermal mass, so we created these concrete panels. We were in a confined site in the center of the city, and so these were the size of a trade truck, and they came precast using green concrete, and they were laid one floor a day, and then a lost form put over the top of these, creating the ducts that you can see in the curve there. That curve also gave us very tall areas where the windows were, so we were getting good light into the building. Next. And this is what it produced. So the system we had is a separation or displacement system where you bring clean air down at the bottom of the office, and that is pushed up and pushes the air that you've been breathing out at the top without sharing it with other people. We have the conventional HVAC system on the left here, and what we know is we're sharing that air with everybody and we're recycling it, which doesn't produce a healthy environment. And I must say, I sat in the COVID situation wondering, as we try and encourage people back to buildings, and Kate's just told us about the risks, how we convince them that this isn't a healthy environment to be in. So I think the research that Dominic's going to do and talk to now is a good lead for the industry as to how they can do it. This is a slide of the office space we created, and gives you some idea. We changed the air 1.5 times per hour, and there was high indoor air quality. We found that the staff did not drop off. Next slide. We also, as we designed this workplace, had low VOC materials. There was no paint in the building, and therefore you didn't get the off-gassing that you get. We also introduced plants into the building, one plant for every person in the building. And that also helped refine and purify the air. Next. You can see here some of the components, the radiant cooling that you got out of the ceiling from night purge, the chilled panels. Next, Dominic. The air coming at 20 degrees and then disappearing up the top at 25 degrees. Next. The night purge windows, so right at the back, just where the N is on night there, you had these windows that opened on the sides of both sides of the building each night and allowed the air through and ventilated the building overnight, but also cooled it. Next. And a typical office, one of the downsides of this, of course, is by getting good ventilation, we actually didn't have enclosed offices. And you can see this office is open, meeting room is open to the top. to allow the night purge to go through. But that seemed to have worked, and people are quite happy using offices of that sort. Next. Next one, Dominic. And this is my second but last slide, but I just thought the interesting thing about this, and this, we didn't realize this when we started designing the building, but as it became more apparent, you can see the costs and the returns there. This building cost 11 million more. It was a $51 million building than a conventional building. And that obviously was a concern. How can you spend that much more money on a building? But the main payback on this building was the productivity. What we measured in this building, and was measured by CSIRO and Adrian Lehrman from the UK, was that you got a 10% improvement in well-being and productivity. And if you value that against the salaries of the people in the building, and Kate talked about the most important element of any building are the people, and that's, that was a philosophy we had. Your return was an annual return of $2.24 million. Energy, we saved 270,000, and that was important. And water, we saved 60,000, and that was also important. But this building paid itself back for everything that we experimented with within 4 to 5 years. Next. So a healthy working environment, as Kate has actually outlined, is no longer optional. You have legal obligations to produce that. So thank you for the opportunity, and I'm going to hand you to Dominic, who will tell you how you can possibly look at retrofitting some of your buildings.
Look, what I take out of your presentation, Rob, is just the importance of reflection, because I guess the lessons that you learn out of something are not necessarily what you expect, and if you can apply that in a different area, like the example of Council House 2 and the fact that well-being was such a strong outcome relative to sustainability, then that's excellent. Okay, so now I'll just hand over to Dominique. Dominique was previously the Director of Place Agency in the Thrive Research Hub at the University of Melbourne. She recently joined the City of Melbourne as a Zero Carbon Building Lead. As a researcher, Dominique is passionate about creating a built environment that is good for people and good for nature. With a PhD in architecture and further degrees in science and engineering, Dominique's research interests range from sustainability to systems thinking and even industrial ecology. She has authored and edited 6 books and over 100 research papers, including the award-winning Designing for Hope: Pathways to Regenerative Sustainability. Today, Dominique will be providing us with an overview of an important research project that investigates low-carbon options for retrofitting buildings to reduce airborne contamination. Welcome, Dominique.
Hi, everyone. I would add my respects to the ones that Rob has just given. I'm calling in from the Boonwurrung lands of the Eastern Kulin Nation. I pay Gillibrooke, which is the local language word for respect for the elders past, present. And I'm really part and joyful to be part of the reconciliation journey. And in context of what we're presenting today, the Indigenous people always try to connect their thoughts and their feelings and their stories to place, to real places, to real situations. And so this particular project that I'm really proud to present to you is about really testing the reality of our potential to reduce transmission through ventilation, while also looking at costs and looking at transmission rates. So if we build from the lessons that we've just heard from Rob, one of the benefits of CH2 was we decoupled thermal from fresh air. So the temperature was regulated through a little bit of tempering of the air, but mostly through the chilled panels. And then the fresh air was brought in through a different system. We provided thermal comfort through the use of radiant water-based systems, so that's thermal. We provided 100% fresh air, we still do. We used displacement ventilation to bring that low flow air in and travelling up like candles, as Rob said, past our heat loads. And it links up the supply air more directly with the external temperature, which has also been shown to be a good contributor to effective productivity and so forth. Yet currently in this COVID era, and we've heard many people at this conference talk about these, there is guidance around how to reduce transmission risks, which is all good guidance, increasing fresh air rates, flushing the building, additional filtration, not recirculating, natural ventilation as much as possible. But these have energy consequences as well, and we often don't speak about the energy consequences. And as much as I completely am with that we need to deal with the emergency that we're in as far as people's health goes, there is no reason, is my thesis in this research, that we can't look after health and look at energy reduction and efficiency as well. So the implications of these ASHRAE recommendations and the things that we're all doing is for all of the buildings in the City of Melbourne that we could increase our energy consumption by 11% when we all come back to our offices. And that's the question that I'm very interested in investigating through this research, and with a nod to our Indigenous people, testing it in place, inside, in context of existing buildings. But existing buildings have a dilemma, and you'll see little quotes throughout this presentation, and they're from the partners that are working with us on this research project. So our retrofit dilemma are often buildings weren't designed for our current HVAC systems. They have low floor to ceiling heights. They have good existing mixed HVAC systems. Thermal and fresh air requirements are combined into the same system in a lot of cases. Floor plates and facades limit what we can do as far as retrofitting, particularly with our modern ways of using our offices. And there's the normal dilemmas, the split incentives, the prioritisation, and so forth and so forth. So within this research project, we brought together a team, and I asked them to investigate 3 options that, through the literature, I found were good ones that we should just test in real life. First one is an in-ceiling Westerflex system with HEPA filters and so forth. It's a low-cost, low-invasive option. Doesn't mean you need to change your floor plate, etc. The second is a personal ventilation system. So that allows control. Yesterday was mentioned, when you go into an airplane, you put your little vent on and you get that fresh air. So it's that same idea. You have that control. You can create a cone of silence, a cone of health around you. Obviously, it has its limitations once you step away from your desk and from your cone of ventilation magic. The third one was a column-based displacement. So this is one of the ones that taking forward from CH2, but within an existing building, what can we do within those limitations in a real context with a column-based system? The reason that column-based system was one that I was particularly interested in testing was because a colleague of mine, Malcolm Lewis, when he was travelling around Australia when I was still at the Centre for Design at RMIT, brought with him these slides. And these were slides that he was asked to create, a research he was asked to create for the Pentagon. If we remember September 11, part of the Pentagon was hit and that part was being rebuilt, and they were doing it in CH2 style with displacement ventilation built into the building. But 3/4 of the building was fine. But then there were going to be the people in the healthy bit of the building and the others. And so the Pentagon wanted to know what could they do with that existing part of the building. So this is the research that he conducted for that. So the standard system at the Pentagon was one that we are very familiar with. We have some supply air happening. We've got people in desks with partitions, and we've got the exhaust coming up. Here, standard mixed ventilation system. So he animated his research. There is a lot behind it, but he animated his research, and you can see that within the first few seconds of this model, everybody has been touched by an increased germ concentration. Possibly the left-hand-most person was the least touched by it, but we have, to a great extent, everyone being affected by that. They were also interested in contaminated mail, if you remember the anthrax scare of the day. Then Malcolm and his team said, well, what would happen if we brought in a column-based displacement system? We do some smart logics about where to move the exhaust system. We have the same scenario, the same lights. We just have this supply diffuser coming here. As you see in the little image on the right, flushing the ground with fresh air. That fresh air then travels past the people and the heat sources and the candles and moves up. And we can see within the same time frame and the same modelling parameters that Malcolm used for the previous mixed ventilation, this displacement ventilation, the person still hasn't sneezed or coughed or opened the letter. You can see that the concentration is very, very low for everyone involved in the office. And here you are, sneeze, and the sneeze or the contamination goes out and away. So I was very keen on having that tested, as well as the other options, which people are talking about. So Cbus Property came to the party and gave me a building to play with until the end of April, hopefully till the end of April when it's being knocked down. So we are working specifically on level 1 and level 10. Level 10 has got sort of an office configuration, so we can test it with partitions and desks and so forth. And level 1, that's where we can test the balances and the implications of the ASHRAE recommendations, where we can install the displacement system and test that and so forth. Our HVAC design and delivery partner is AG Coombs. Seed Engineering is providing the task air for the personal ventilation, and Westerflex is providing the in-ceiling for filtration, and Oricon will be doing the peer review of it. The University of Melbourne is doing the research, as I said, and they're looking at testing these parameters. So baseline, ASHRAE recommendations, the in-ceiling system, and the displacement/personal ventilation system. This is the time frame, and as you can see, Cbus offered us the building in the middle of December. By January, we had all the contracts signed. By February, we were on site. What I'm here, and this is a world first, I have to share with you some of the outcomes of our sort of baseline, particularly the visuals, hopefully by the end of April we will have the full tests complete and be able to show you everything. Professor Monty is leading the research from the University of Melbourne, and he has researchers Grant and Kevin working with him, as well as some research assistants, Max and Liam. So I'm really pleased to be working with such a wonderful team. So within the mixed ventilation test on level 10, so that is that. So this is us testing the baseline of the existing system. So is it doing what our models expect that it would be doing? So here we have the smoke, the lasers, and we can see that as we expect, the air is coming from the diffuser across the ceiling, and by doing that, it's creating this little eddy of circulation, which is part of the issue of this mixing of the virus and contamination and transmission and other aspects. Because it's beyond, the opportunity here is beyond our current pandemic, right? If we provide healthy environment quality, Steve Brown back in 1998 did some research that showed that there is a $12 billion opportunity by improving our air quality in our buildings. So, it's not just for now, it is forever how we can improve things. The second bit of testing was, we've heard that the cough will travel, the particulars will travel. Is that true within the standard mixed ventilation within our context, so that we can then test it within the other contexts in later iterations? The research gives us this sorts of information, and we've simulated the cough with, and the researchers have done the verification around this with a very simple 3-litre milk container that they squish, and that then travels. And so we measured how far does that travel, and indeed within our measurement within this system, from that table in the centre, that round table, to the person sitting at the very right, that would have travelled, and they would have been touched by it, if not necessarily infected. Of course, there are other aspects to that. The next thing that we wanted to try out was, within, again, the mixed ventilation context, do partitions help or hinder? And that comes from some other research that talks about heights of partitions and the impact that the heights of partitions have on that potential transmission. So here we have the setup. We have a chair where the person will be sitting and coughing. We have the partition, and we have a little gadget there that measures the increased particulates on the other side of the partition. Here we have Liam doing the cough, and you can already see through the smoke that is travelling over the partition and down, as expected. Now, these are simplifications and visuals to help the narrative. The researchers are collecting the data. We're collecting energy data. We're collecting, so they're using a saline, vaporized saline to measure the particulates. And we're using the smoke and the lasers more as a communication mechanism. What our little instrument there showed was a 20% increase in the particulates that were hitting that side. So definitely the mixed ventilation was sending that cough, that sneeze across to the person sitting at the other desk. So the outcomes that we intend to have through this project is we want to have a preliminary idea of the energy use aspects, the cost per square metre of the retrofit options, and the infection control potential of the retrofit options, as well as the base case, and also have a serious look at what is being recommended through ASHRAE and others. We want to test the real world context of these options with local suppliers, local consultants, local equipment, local tradies to implement it, local researchers. With you all on this project, what does it mean for us? We're testing different scenarios and potentially, and we'll need to see where the research goes, enabling us to do a mix and match. So potentially the column displacement is not possible, but does the personalised system plus mixed ventilation, does that provide? So it will enable us to do that mixing and matching. These are real outcomes to verify modelled predictions of energy use and transmission, which will feed back into everybody's models. This is a benefit internationally. In fact, Professor Monti said that this is the first international study of this kind that he has come across. Nobody has put these things together and done it in a real world context. So congrats to everyone that's participating in this. This pilot will feed into a citywide retrofit research project called URIC, being spearheaded by Professor Sarah Bell, in partnership with CFMEU and other unions like the plumbers and electrical, etc. So it's a very exciting project collaboration that has the potential to really ramp up. I'm hoping that it will create a really good, robust community of practice around the potential of retrofits and improved wellbeing outcomes and energy outcomes. I don't think we need to trade those two off, but nobody has done the research to actually look at that in real life. And you know, City of Melbourne, we want to support our building owners. They are part of the vibrant life. They bring the workers to site to find the best cost options, most effective for decision making. So here are my contact details. Feel free to shoot me an email if you do want to become part of our community of practice, if you do want to become updated with the outcomes of this research, if potentially you have ideas about a next stage for this research. We're very interested in having these conversations with you all. Thank you for your time.
It's great to see a research project that's taking such a collaborative approach and that is so engaged with industry. And I guess the sustainability outcomes of improving ventilation is a topic that's been much discussed within the industry over the last little while. So having some research looking at that particular issue is so important, and we look forward to the results. Okay, now I'd like to welcome Tim Wheeler to moderate a discussion with Kate, Rob and Dominique on what the future might hold for our workplaces, offices and cities. Tim is currently the Acting National Policy Manager for Sustainability at the Property Council. He holds a master's degree in environmental science and law from the University of Sydney and a bachelor's degree in science from the University of New South Wales, both of which he puts to good use with his passion for public policy in the area of sustainability. Prior to joining the Property Council, Tim has held positions with the Federal Government, the International Energy Agency and the Green Building Council of Australia. Welcome, Tim, and over to you.
Thank you, Ben, and thank you to the AMCA for hosting such a timely and necessary conversation around ventilation. I'd like to also add my respects to those who've come before me and pay my respects to the Guringai people on whose land I'm calling in from today. So we have some questions coming through from the audience, and I'd encourage you to keep sending those through, and I will get around to them where I can. So I might start with a question for Rob that's come through. So CH2, when it was originally conceived, was meant to be a lighthouse project for new building developments and aiming to influence future designs of buildings down the track. Has it been successful in influencing design of buildings that came after it?
Tim, I think it has. There's no building that is exactly like it, but I think the one thing it did was that it encouraged developers to try and better CH2. Every developer likes to say they've got a better building than the one that's come before. And in trying to better CH2, the standard of building and the number of 6-star, Green Star buildings in Melbourne rose quite dramatically, particularly down in Docklands, which was an area that was under development in about 2006. Unfortunately, I don't think the major component of it, which was the fresh air environment and the displacement system that we put in place, has been replicated too often. And I think that's absolutely crucial. And I think the work that Dominic's doing shows that this isn't a difficult thing to do, even with a quite confined building that you have today.
We've seen that slide that you presented on the excellent air quality that is apparently available in the rooftops of Melbourne. The IPCC tells us that extreme events are going to increase over time in severity and intensity. How did CH2 fare during the bushfires?
It was fine. Look, there is the ability to, in fact, temper that air slightly as it comes in. But I wasn't aware of any complaints coming from people who were in the offices over that period. There are obviously going to be those, unusual occurrences, no more unusual than COVID. And I think, the building might find that on certain days, if the air quality does become very bad, that, the workers are encouraged to work from home that day. That's something I think we're all going to learn to pivot and adjust. And I think those adjustments can be made quite easily with a building like this.
Terrific. Going to the question of working from home, I've got a question here for Kate. Does the presentation that you presented on before indicate that if people can work from home at the moment, that is still the safest option, and that's the way that they should be trying to schedule their work plan?
Well, if it's practical for the work that they do, absolutely. I mean, why not? I think that there was a huge reluctance about employees generally working from home before the pandemic. Maybe that's because employers thought maybe they're not as productive, or we don't have the right tools in place, we're not going to get the same type of interaction. But I think we've shown that to be wrong. And in fact, working from home has some huge benefits. And to be honest, also potentially opens up the potential, employees that you may not have had access to previously. Like just one example, within my own workplace, we have employees that live in regional New South Wales working on really big projects in the city of Sydney. And their work is fantastic, and they're able to contribute to those major projects, even though they live remotely. So there are advantages. It's not going to work in every workplace, but providing employees the option about what works for them best, I think is a really good place to start.
Terrific. And we've also seen on a similar topic, a lot of debate around whether masks should continue to be worn in offices at the moment. One of these slides that you presented on had a hierarchy of controls. And I was wondering, maybe over time, will that hierarchy evolve as COVID becomes endemic? And will we see a relaxing of these types of measures in office spaces?
Well, it all relates to risk. The hierarchy won't change and the effectiveness of masks won't change, but the risk will change. And I think it's a really important thing to remember is that public health measures or what's in the public health order doesn't negate an employer's responsibility or accountability for their employees' work health and safety. So even though it might be removed in, I don't know, Premier or Department of Health comes out and says, well, they're not mandatory. Has the risk changed in the workplace? Are we still in a pandemic? Do we still have high levels of community transmission? And if you remove masks from your workplace and you have workers that are relatively close to each other, or if you have quite poor ventilation, then how are you as an employer actually mitigating that risk appropriately? And we know that each one of these measures that we have in place is not 100% perfect and a layered approach is needed. So I guess I would encourage employers to reflect on their own risk assessment and make sure that before they decide one way or the other to remove masks or to change the type of mask that they may require to be worn in their workplaces, that they reflect on that risk assessment and make sure that that's a risk-based decision and don't just blindly follow a public health order thinking that that's sufficient to discharge your duties under the Work Health and Safety Act.
That actually raises a really interesting question around the WHS legislation that is in place here. In the built environment and across the board, I think we consider legislation that it's often drafted as a minimum standard rather than best practice. Should building owners and managers today be looking to exceed what is put forward in the legislation, and should they be striving to outperform what's on there?
Well, legislation is performance-based. So generally we won't see, unless it's in a code of practice, and as we know, we don't have amazing standards for indoor air quality in buildings, and that's definitely a gap that we need to fix, so which I'm all for. But we're not going to find a level of prescription around it, which is why employers need to do risk assessments of competent people, and it needs to be relevant to their own workplaces. I guess back to my original point, the most important people to an employer should be, and arguably the majority of times is, their workers. So it's really about consultation with the workforce. That's a huge key part of risk assessment. It's not about a team of management or management consultants writing a risk assessment and applying it. It's about consulting with the workforce and understanding their challenges and their needs and having them part of that conversation so that they can contribute to what needs to be done. And so that there's not really a fine dividing line between compliance and best practice. It's really about, we've done a risk assessment, we've done it in consultation with our workers. This is really practical. This is going to work for us as a business. Everyone's going to be happy with this, or majority of people are going to be happy with this, and let's move forward. I think where we get challenges is when you have an employer, well-meaning, that says, oh, look, these are the rules, and I communicated on an email. It generally doesn't end well.
Right. Dominique, I saw you react strongly when Kate suggested that we needed a standard for indoor air quality. What solutions should we be exploring in that space?
Great question. I think yesterday, there were a few people that talked about the need for some sort of standards for indoor air quality and some sort of regulations that require a level of not just designed air quality, but actually experienced air quality. So some sort of neighbours disclosure element, I think, is critical to this. We need to be able to measure it. And I did hear the comments around our current instruments being, we can't afford a $100,000 instrument. We want the $10 instrument, but the $10 instrument at the moment doesn't provide us the verifiability, if that's even a word, that we would require for regulations. But I think we have smart people. We have the technology. I think we can cross that one. And the process of bringing regulation in takes a while. So I'm sure they could happen in parallel.
Interesting, and I think you've touched on something really key there, which is that some large, sophisticated bodies will have a lot of means at their disposal to try and solve this issue, whereas others might be much smaller operations, potentially without dedicated people for the sustainability or indoor environment that they would have within their buildings. Do you think we'd be able to land on something that would work across the board? Or will we always need a bespoke set of measures for a particular building?
So you're talking to a scientist, engineer, architect person as opposed to a regulator, policy, governance person. I think we're smart people and I think we can figure it out. I think we have our phones, we have our smartwatches, we have the capacity to create technology. At the end of the day, what building owners want to show their building occupants is that it's a great building. It's good to come back. They've done everything they can. They've offset their risks, etc. This is a way of demonstrating it. I think it's very viable. Whether we want to go down the regulatory, maybe we don't. Maybe people just do it because it's the right thing to do and it will attract people to their buildings. And that is the ideal scenario, right? Making people do something is much harder than them wanting to, because it's a good idea and it's, they're doing the right thing by their occupants. So that's part of the conversation. So again, not a regulator, scientist, engineer, possibly hopeful optimist over here.
Kate, we have seen so many different disciplines involved in this really interesting forum that AMCA has pulled together. We've seen mechanical engineers, scientists, architects, occupational hygienists, policymakers. How do we get everybody to work together in this space to deliver the solutions that we need?
Oh, that's a really good question. I think we're already many steps ahead because we're all the professions that you've mentioned, and arguably there's probably a few others, are really purposeful professions. We're here for a reason, and it's a really important reason. We all want to contribute positively to things. In many ways, each one of our professions are problem solvers in our own way. And in my experience being on panels and task forces, I've found it really enlightening to work with other really purpose-driven professions. But in answer to your question, what can we do? I think summits like this are very good at bringing people together and enabling the connections that maybe people didn't even know that certain people or certain professions existed, and to reach out. I think that working on and promoting standardised guidance and tools, continuing to write to and advocate through different state and federal governments as a collective is really important. When we have something that's really passionate to us as an industry, to reach out to other professions and seek their input and their advice before we go out all guns blazing on something that we think is really important. And we've seen that done really well over the past 2 years. And I think us as a collective community, the wider community, of people that understand that COVID is airborne. It's a very bespoke community that sort of got it quite early. I think we're quite good at reaching out. The epidemiologists, the hygienists, the aerosol scientists, engineers, architects, all good, right, at coming together. So I think we just need to leverage our strengths as a scientific or engineering wider community a bit more and not give up, because in my experience, a lot of all the work I've ever done on COVID is purely in a volunteer capacity, and I'm sure that's the same for many speakers at this summit, and indeed in other professions. We've donated our time for a good cause, and sometimes you can get a bit down with it. It's continuous battle saying the same thing. But one of the beautiful things out of this pandemic has been getting to know other professions, other people in this space, and we've created a really great supportive network and community. And so continuing to have events like this that bring us all together to create alignment is really important.
Words to live by, Kate. Rob, coming back to CH2 briefly, you mentioned that the additional sustainability items that were added to that building cost around $11 million, which is quite a substantial amount. I think it was about 20% of the total cost of that building. Today, Green Star, to achieve a 6-star rating, according to the Green Building Council's business case for Green Star, it would only be about 2.5% of the cost of the project to deliver a 6-star Green Star building. Is this something that initial projects like the one that you developed through CH2 have paved the way for? Have there been learnings over time that were created through business cases that could only be undertaken by government at the time and now have become spread throughout the industry?
Yes, I think that was the case. And, CH2, as I said at the start of that presentation, was very experimental. And we tried to do more than you would try to do in any one building. I mean, we tried sewer mining, which was taking water out of the sewer, filtering it, and then reusing it. And what we discovered quite quickly was that in that part of the city, for instance, there's a lot of cafes, restaurants, and there's a high grease level in the water, and it actually just clogged up the filters, and it was very expensive to do. So the learning out of that is don't not do that, but maybe do it at a precinct level and get a water authority that's better equipped to handle that part of the process. We also tried using the shower towers, which are you dropping water through 15 meters and it cools as it goes down and you get cool air and cool water. And we were pushing that cool air into the retail areas and then putting the cool water in a phase change, which is like a sophisticated ice block that holds that cool energy until you could recycle it through the chilled ceilings. Many of those things we found were interesting technologies, but mostly not the sorts of things you would recommend to the industry on a broad level. So what it came down to at the end of the day is that some of the simple fundamental things like having a building with thermal mass that you could open the windows and use the cool, evening summers to cool down the building and then lock it down during the day, much as every Victorian house has done for, decades. Those were the things that were important to pass on to the industry. And the whole thing of ventilation. I mean, we battled to get that message across. For ourselves, because we own that building, we get the direct value of that benefit back to our people. In many cases, developers own the building and they lease it out. And so they're not realizing that value. So there was a resistance in moving to that extra expenditure to provide what would be a good building. We're now placed in the situation with COVID that, many people are going to look at buildings very carefully. What is the ventilation system like? What is the air quality? And, they're going to be making choices about whether they want to work in those buildings. So I think the pressure comes back on to, building owners now to look seriously at how they do produce healthy buildings in this new environment. Because if they don't, people will opt to work somewhere else or work from home. And we don't want that to happen in the city. I mean, we want people to come back into the city. And that's why I think, the work that Dominic and the group are doing is so important, because I don't think it's going to be an expensive retrofit. And I also don't think we should be knocking down buildings to create this healthy environment, because the embedded energy in knocking down a building and rebuilding it is huge. So retrofitting and transforming buildings is important. And people say, is that possible? Well, we showed with Postcode 3000 where we retrofitted office buildings for residential to bring the residential population back into the city. Could work. And we were told 1,000 times it wouldn't work. But in fact, Melbourne is now a residential city in the CBD. And that was through a program, Postcode 3000, that started by retrofitting buildings. So this is not difficult. We just need to get the mindset that this is now necessary. I mean, it was never optional that people should be not working in a healthy environment. But people have not paid much attention to that. Now people are going to pay attention to it, because there's litigation that will come on the tail of this if people don't produce healthy buildings.
So really, COVID has shone a light on something that has been a problem for quite some time, and hopefully the actions that are taken today will help to solve many problems that go beyond the issue of transmitting COVID within buildings.
Yeah. And I'm optimistic. I mean, COVID's been a terrible thing. But as someone who's worked with cities now for, over 40 years, COVID will actually give us better cities in so many ways. I mean, we'll get better buildings, better ventilated, healthier buildings. We'll also get better local areas because people are actually spending more time in their local areas. So the whole of metropolitan Melbourne, I think, will ultimately benefit from adapting on the post-COVID environment.
You mentioned a value uplift in productivity and well-being that was generated by the measures incorporated in CH2. How were these calculated?
Excuse me. What we did is we, CSIRO and Adrian Lehrman took one of our original buildings and looked at the indoor air quality and the productivity and measured that, and then measured against what happened when the occupants moved into CH2. And their figures, in actual fact, were possibly higher than the ones we've used. But we've established a figure of about 10% improvement in productivity and well-being. And that gave us that figure based on the salaries of the people in CH2 as to, the savings you were making by having people working in that environment. And I mean, as a sample of one, I've always suffered from sinuses and things like that. And when I went into a conventional building, I got dried out and I had nasal sprays. Experienced nothing of that in CH2. You go in, the plants lasted in CH2 much longer. In fact, they weren't being taken out every 3 months to be, recuperated. They, in fact, just survived and carried on, flourishing. So there were a whole lot of indicators, but that was the uplift. CSIRO and Adrian Lehrman, were the two people who did that for us.
Terrific. Dominique, I think some of the visuals that you presented today were great. I think I'll always be visualizing a green plume whenever anyone coughs around me from now on. Is it possible to retrofit displacement ventilation to most existing buildings that have mixed ventilation at this point?
That's one of the things that we're testing. So usually displacement mindset, we want high floor to ceiling so that we can get that differentiation in temperature, that stratification and all of that. So that's part of what we're testing. So we're measuring the temperature and so forth with AG Coombs installing and designing the displacement system and the University of Melbourne putting in all of the sensors and so forth to test those aspects. Hopefully we will show, as my colleague Malcolm's work showed for the Pentagon, which was quite a restricted floor-to-ceiling height space, that it is possible, but it might require some smarts around how we extract air. We always worry about the supply, right? But maybe we need to be more proactive around the extraction and so forth. So, but this gives us the opportunity to play with those. Does it work? Does it meet the modelling? Do we need to adapt the modelling and so forth? My expectation is that, as I've said before, I think we can do it. It may be a combination of technologies and smart people sitting around saying, well, these are the options. How do we provide the most effective solution for healthy offices?
And I know that obviously the results for the study are not yet published. The things that you'll be looking into is energy efficiency. And in particular at the Property Council, a lot of our members have got very ambitious sustainability targets. A lot of our large members have got net zero by 2030 goals or even before. Do you think there will be a clash of interest here between getting clean air into our buildings and the energy efficiency and associated emissions that could be created by increasing the ventilation rate or opening windows more?
I think it could be perceived as such, but that would limit our ability to find the solutions to this. I think that there is a relationship that we need to explore. And once we understand that relationship, we will be able to work towards it. And maybe we do need to invest a little bit more energy into creating healthy environments, but it probably isn't doubling the energy we need for the provision of fresh air, which is what it's looking like, or 11% of our total energy consumption of a building. It doesn't need to be that. It might need to be a little bit, because at the end of the day, if a building doesn't provide its function and a place for people to be healthy and thrive and vital, then there's no point to it, right? So there may be a compromise, but we're not even having a discussion around what that is at the moment. And this research is about showing that it's possible. But the other research that underpins the rationale for doing this work is that if we can decouple the air from the thermal, then the opportunity is to actually save 11%. So instead of increasing 11%, we could save 11%, again, through potentially having a 15-year retrofit plan where we do what's needed now, but we then use that equipment in the future and then decouple the systems and so forth as plant needs to be replaced. So I think the current way of trying to solve it quickly is increasing our energy, but that doesn't mean that's the solution for the future.
Great. I'd like to just socialise some data that we've collected at the Property Council as well. So we sent out a survey to many of our leading members with commercial office buildings about the number of cases of COVID that they had in their buildings and the number of people who were contaminated as a result of those initial cases that turned up. We surveyed a total of 140 commercial office buildings over a 4-week period. Now, I must say this was in November last year, so it was a different context to the one that we're operating in today. This was during the Delta strain of COVID, and Omicron wasn't yet on our radars at the time. But of those 140 buildings, there were 27 independent cases of COVID that were detected within the buildings. And from those 27, an additional 7 people were contaminated. What we found, though, is that there were no people contaminated in separate tenancies and no people contaminated in separate floors either. Is this an indication, perhaps I would open this to anybody who'd like to answer it, is this an indication that the measures that have been taken by a lot of building owners around night purges, better filters, a higher mix of fresh air, is this an indication that all of that is working and that we're not seeing COVID transmitted through ventilation?
Tim, did you work out the percentage occupancy of the floors people had in November? Because I was in the office in November and there were 4 of us on the floor. I think that makes a difference.
Yes, so it was overlaid with the Property Council's data collection on office occupancy. And this was across Australia, so it wasn't just Sydney or just Melbourne. And there were varying rates of occupancy there. But I think that would have to be a factor that would be considered. And of course, there were much fewer cases around in Australia in November last year than we've seen with Omicron and the reopening of the economy this year.
I would add to that the measures that have been recommended, the air changes, the natural ventilation, don't recirculate, etc., are there for a reason. They're there because they work. It's just there's a bigger picture to look at. And so I think that's part of it. Part of it's also people's behaviour, wearing masks, washing hands and so forth, wearing their masks properly, Kate. So I think there's a lot of factors to it. But I think, yes, density is very important in that question.
Kate, any views from you?
Yeah, I guess from my perspective, it's really difficult to take data from Delta and apply it to Omicron. And it's really difficult to look at November, where we had relatively low occupancy, to what we're about to go into, which is workplaces going back. So arguably, you are about to get a significant order of magnitude higher number of data points to help inform that. But I wouldn't say that that's conclusive. And that's really the challenge. If I look at it from our workplace health and safety lens, it's essentially taking a precautionary approach. It's putting things in place to prevent illness or something happening. And so with reference, this is why we have all these measures for ventilation in place, and why we've, I guess, put some blanket guidelines out around ventilation. But it doesn't mean we know everything. It's all around the dose and what was the amount of infectious dose that were in those offices. And if that infectious dose was higher, would you have a different outcome? I would say that it's likely that your infectious dose was quite low due to the occupancy. So I think all data is great, but it's how it's interpreted. And I guess for us that have been banging on about airborne transmission for so long, we've seen how some stakeholders that potentially were a bit slower at understanding that airborne transmission is a thing, have twisted data and studies in certain ways to demonstrate why we don't have to do anything. So I think in this context, we need to keep that in the back of our mind. So rather than using data to say, do we not have to do anything? It's about using data to go, should we be doing anything else? Because we don't know the answer to everything yet. We know what we know, but we know that we've got this whole sphere that we don't. So I guess that's my take. It's not conclusive.
Thanks, Kate. And actually, there is an interesting point that you raised there as well, which is there are the technical side of things that can be done for buildings, but there is also a psychological element to returning to our CBDs and returning to our workplaces. Kate, your field of expertise does involve the communication of this to workers and people as well. What messages can we be putting out there to encourage people back to our workplaces?
Well, firstly, I'll say that people aren't silly. So telling people that it's safe to come back is generally not effective if you haven't done anything to make it safe for them to come back. That actually hampers the efforts. And generally, people want to come and see people. And if they have feelings of, that they're anxious or they're a bit worried about coming back, again, repeating the message, oh, it's safe, just get out there, doesn't generally help. What does help is being really clear about the measures that are in place to keep people safe, so that individuals can take on board that knowledge and do their own sort of individual risk assessment of, is this enough for me to come in? So, communication around, well, we have QR codes and hand sanitizer generally is not helpful. What is helpful is to explain, look, we've done a risk assessment, we've engaged competent health and safety professionals, hygienists, ventilation engineers. We've reviewed all our ventilation system. We have maximised fresh air intake. We've gone into the building, we've tested it, and we've put these additional measures in place. And if you would like to wear a mask, by all means, or we are still wearing masks indoors, or we have continued to review occupation density. So we have reduced the amount of occupation in that space. The other thing is really harnessing the value of flexible working to make it more amenable for people to want to come back. So, and I'm talking in an office context, obviously, but this old rhetoric of, well, you must be in the office by 8:30 and you can't leave till 5 really doesn't work with airborne transmission, because what happens is you just create this potential infection risk disaster where everyone is using the lifts at exactly the same time in the morning and everyone is using the lifts exactly the same time in the afternoon, and people have only focused on the actual office and given no regard to the lift, which is arguably where transmission would likely occur given the close proximity of people in that space. So flexible working, flexible time to enable people to come in and out, trusting your people that genuinely, if we're working, we want to work and we want to do the best that we can. And I guess open and clear communication to help people make their own determination to bring them back. Because, it's the same for me. We're about to go back and be welcomed back into our office spaces. And I have comfort to know that there has been measures in place to keep us safe. So we're more likely to go and visit in a face-to-face context than if nothing had been done.
Okay, could you also talk to the duality that we see between people coming to the office and expecting a very clean, sanitized environment, and then after work at 5 o'clock, they clock off and they go all to the pub and they sit shoulder to shoulder at the counter, and there seems to be a big disconnect between how those two environments are viewed.
Yeah, absolutely. I think what we do in our personal life and the personal risk profile that we accept is one thing, but when we go into a workplace, there is a different risk tolerance threshold, right? Employers have an obligation to keep us safe. We have an obligation to follow the rules that are put in place, or the guidance or the standards that are put in place to keep us safe. So that's very different to going to a pub. So we can't just use one scenario and say, well, we do this, so let's not care about what happens in this context. We've seen kind of the same thing happen in schools. So they go, well, kids play outside all the time. They play in the park, whatever. Let's just throw them back into the classroom. And in my own context, half of my son's school class is out because they all have COVID. So I think we must be really careful not to confuse the two. We have work health and safety legislation. We have all this stuff to keep people safe in the working environment. People should expect a safe workplace. That's a minimum expectation. It's 2022. We're in Australia. I think that should be a given. Unfortunately, it's not always, but that should be a given. But I guess your own personal risk profile that you have if you go to the pub or you go to the restaurant, I mean, that's up to you. But I would generally suggest that if we are doing those things, that remember that, SARS-CoV-2 doesn't know if you're in an office or if you're in a pub. The infection risk profile is not different because you've chosen to go to a poorly ventilated space. It's still going to infect you in the same way. So hopefully people will take that information and knowledge on board and visit establishments that have great indoor air and monitor their indoor air and show their customers that they are taking this seriously, which hopefully would improve or increase the amount of customers that may visit their establishment because they would feel safer by doing so.
Terrific. I have just been notified that we're running out of time, so I'd like to thank all three of our panelists, Kate Cole, Dominique Hess and Rob Adams for your insights, and I will send back to you, Ben.
Thank you, Tim, Kate, Dominique, Rob. I guess just unfortunate that we needed to cut it there. I get the sense that you could have all spoken for a lot longer than that this morning. And I'm really glad that you touched on the fact that there's so many brains working on this issue from so many different disciplines and that there's an enormous amount of goodwill at the moment around this issue. Just in speaking with people today and yesterday, you really get that sense. So I'm glad you touched on that. And look, I do know that there was a particularly strong interest in this session. Obviously, we've been talking about things around regulation and policy and technical challenges and things like that. But I think the crux of the discussion this morning between you all has been around people, and people gravitate towards conversations about people. So thank you very much for your time and your generosity, not just today, but in the lead up to today.
We would like to thank our event partners for supporting the Building Ventilation Summit.